Alright, PreCal, on the first part of this review, you're going to have to find all 6 trigonometric ratios for both the alpha angle and for the theta angle. So the piece of information that's missing here is this leg right over here, and you're going to find this leg by doing the Pythagorean theorem, or you can see that that's one of your Pythagorean triples. That is your 5, 12, 13. So this piece right over here is 12. Now let's go ahead and do those alpha ratios first. So here's your alpha. So we're going to do sine, which is so, opposite over hypotenuse. So that's 5 over 13. And that means that cosecant is going to be 13 over 5, because remember that's your reciprocal function. You're going to have to memorize those in order because that's the way I'm going to expect to see those on your test tomorrow. Alright, now cosine is adjacent over hypotenuse, which is 12 over 13. That means that secant is 13 over 12. And then tangent is TOA, opposite over adjacent, so that's 5 over 12. And that means that cotangent is 12 over 5. Okay, now we're going to switch over to the theta angle. So now we're going to work off of this angle right here. So sine of theta is opposite over hypotenuse, so that's going to be 12 over 13. That means that cosecant is 13 over 12. Cosine is ca, adjacent over hypotenuse, and that's 5 over 13. And that means that your reciprocal secant theta is going to be 13 over 5. And then your last two are tangent theta, and tangent is TOA, opposite over adjacent, so that's 12 over 5. And that means that cotangent is 5 over 12. Okay, let's move on to the next problem. And it says that cosine theta is 7 over 25, and you have to find the other 5 trigonometric ratios. So, first thing you have to do is draw your triangle. So, I've got this triangle written in standard form, and I have cosine, so I have adjacent and hypotenuse. You need to pick which angle, which acute angle you want to call theta. I just call that bottom right hand my theta angle. So cosine is ca, adjacent over hypotenuse. So that means the adjacent piece is 7, and the hypotenuse is 25. Now, you can do the Pythagorean theorem here, or also this is a special right triangle. So this piece over here is 24. And now we have to do the other 5 trigonometric ratios. So sine is opposite over hypotenuse, so that's 24 over 25. Cosecant is just the reciprocal, so 25 over 24. Now, I gave you cosine, so you can do secant because that's just the reciprocal, 25 over 7. And then tangent is TOA, opposite over adjacent, which is 24 over 7. And then cotangent is that reciprocal, and that's 7 over 24. Alright, let's go on. The next problems are your special right triangles. So, this first problem, now, it doesn't have any angle measurements, but it shows that it's an isosceles right triangle. That means that these angles are the same. And since both of those angles are the same, it means that they are 45, 45 right angles. So the pattern for a 45, 45 right triangle is A square root of 2. So the piece that we have 25 is A square root of 2. So we have to algebraically solve that. So I'm going to come over here and do that work. So I've got A square root of 2 equals 24. Divide both sides by the square root of 2. I have to rationalize that answer by multiplying the numerator and the denominator by the square root of 2. So that gives me 24 square root of 2 over 2. Now, the 24 halves needs to be simplified to 12 square root of 2. So now both of these pieces are 12 square root of 2. And make sure on the test tomorrow that you do label both of them because those are both answers, the X and the Y. Okay, let's go on to the next page. These are still our special triangles, and the very first thing I'd like you to do is make sure that you label these. These are your 30, 60, 90. So on your 30, 60, 90s, opposite the 30 is A, opposite the 90 is 2A, and opposite the 60 degrees is A square root of 3. So let's go ahead and label B. So opposite the 30 is A. So this piece right here is A. Opposite the 60 is A square root of 3. And opposite the 90, which is the piece that you have, is 2A. So if 2A equals 40, just like this, you divide both sides by 2, so A equals 20. So now you can actually answer X and Y. So this side over here, that's Y, is just A, so this is 20. And then X is A square root of 3, so that's 20 square root of 3. And again, you have to make sure on the test tomorrow that you label both sides because both of those are parts of the answer. All right, problem number 4. I've got that tangent theta is 5. I need to find cotangent and secant. Well, the first thing I need to do is I need to make tangent look like a ratio, so I'm going to make that 5 over 1. And then that means I can answer cotangent theta right away because it's just the reciprocal, 1/5. Now, secant is the reciprocal of cosine, so I need to go ahead and figure out what cosine is. So I'm going to start by drawing a right triangle, and I'm going to do my work off a tangent. So tangent is TOA, opposite over adjacent. So this is going to be 5 over 1. And then the hypotenuse from the Pythagorean theorem, sorry guys, is 5 squared plus 1 squared, which is 26. So the hypotenuse is the square root of 26. Now, again, secant theta is the reciprocal of cosine theta, so I'm going to do cosine theta first. So cosine is adjacent over hypotenuse, 1 over the square root of 26. I'm not going to do anything with that because I don't need to rationalize it because the answer that I want is secant, and secant's just its reciprocal. So it's the square root of 26, or you can write the square root of 26 over 1. Remember, if your ratio comes out a whole number and you just write it as a whole number, that's fine. Or you can put it over 1. I don't care. Either way will get you full credit. All right, and let's go to the next problem. So the next problem says that cosine theta is equal to 0.2. Well, if we say 0.2 correctly, it's 2/10. Well, I'm going to take that 2/10 and simplify that to 1/5. So that means that cosine theta is 1/5. So that's adjacent over hypotenuse. So I need to figure out the opposite side. So I'm going to do the Pythagorean theorem. In this case, it's actually subtraction. So it's 25 minus 1 is the square root of 24. And then you guys, you have to rationalize that. So that's 4 times 6. So that piece is 2 square root of 6. So now we're going to find sine. So sine theta is so opposite over hypotenuse. So 2 square root of 6 over 5. So that's sine. And then tangent is opposite over adjacent. And opposite is 2 square root of 6, and adjacent is 1. So there's the other two. All right. And then the last thing that I said that would be on here for this first part is where the trig ratios are positive and where the trig ratios are negative. You guys are just going to have to memorize this. Okay, that's the end of the first part of the review.